Welcome to the class where numbers play. We count, add, and dance. Come on and stay. Minus here, add there, feel the beat. Numbers on the move, can't take a seat. Multiplying wild, subtraction's cool. Jump into the groove, arithmetic's the rule. Fours and fives, we break it down. Oh yeah. In this math jam, don't wear a frown. Multiplying wild, subtraction's cool. Jump into the groove, arithmetic's the rule. Fours and fives, we break it down. Oh yeah. In this math jam, don't wear a frown. 1, 2, 3, 4, let's add more. Feel that number, groove, dance on the floor. Subtracting beats with every spin. Arithmetic's our jam, let's win. Tables turn, figures fly high. Division in the mix, math in the sky. Keep the rhythm tight, keep the sums. Count to the beat of these banging drums. Arithmetic flows, it's how we roll. Feel the numbers move, let's take control. Adding up the joy, subtracting fears. In this gritty groove, math is cheers. 1, 2, 3, 4, let's add more. Feel that number, groove, dance on the floor. Subtracting beats with every spin. Arithmetic's our jam, let's win. One, two, three, four, let's add more. Feel that number, groove, dance on the floor. Subtracting beats with every spin. Arithmetic's our jam, let's win.
This introductory arithmetic course is a foundational component of the J.O.L.A.L.F Introductory Journal course, designed to equip aspiring digital linguists with essential mathematical skills. As a digital linguist, a strong grasp of arithmetic is crucial for various tasks, including data analysis, algorithm development, and understanding the computational aspects of language processing. This course will cover fundamental arithmetic concepts, including basic operations, addition, subtraction, multiplication, and division of whole numbers, fractions, and decimals. Number systems, understanding different number systems, such as integers, rational numbers, and real numbers. Order of operations, mastering the correct order of operations to solve complex mathematical expressions. Problem solving, applying arithmetic principles to solve real-world problems and analyze data related to language and linguistics. By successfully completing this course, participants will develop a solid foundation in arithmetic, a vital skill set for their journey towards becoming proficient digital linguists. Arithmetic is the foundation of mathematics, dealing with the fundamental operations of numbers, addition, combining numbers to find their sum. Subtraction, finding the difference between two numbers. Multiplication, repeated addition of the same number. Division, sharing a quantity equally among a group. These operations are essential for everyday life, from simple tasks like counting money and measuring ingredients to more complex calculations used in various fields like science, engineering, and finance. Arithmetic provides a crucial framework for understanding and solving mathematical problems, and it's a vital skill for everyone. Course syllabus, Introductory Arithmetic. Course description, this course provides a foundational understanding of arithmetic concepts essential for success in various fields, including data science, computer science, and linguistics. Participants will develop a strong grasp of basic operations, number systems, and problem-solving techniques. Course objectives, upon successful completion of this course, students will be able to perform basic arithmetic operations: addition, subtraction, multiplication, division with whole numbers, fractions, and decimals. Understand and apply the order of operations PEMDAS BODMAS. Work with different number systems, including integers, rational numbers, and real numbers. Solve arithmetic word problems related to real-world scenarios. Apply arithmetic concepts to analyze data and solve problems in the context of linguistics. Course outline, Module 1, Basic Operations. Whole numbers, addition and subtraction of whole numbers. Multiplication and division of whole numbers. Properties of whole numbers: commutative, associative, distributive. Fractions, types of fractions: proper, improper, mixed. Addition, subtraction, multiplication, and division of fractions. Decimals, place value and decimal operations. Converting fractions to decimals and vice versa. Module 2, Number systems. Integers, definition and properties of integers. Operations with integers. Rational numbers, definition and properties of rational numbers. Representing rational numbers as fractions and decimals. Real numbers, definition and properties of real numbers. Understanding the number line. Module 3, Order of operations. PEMDAS BODMAS, understanding the order of operations (brackets), exponents orders, multiplication and division, addition and subtraction. Applying the order of operations to solve complex expressions. Module 4, Problem solving. Word problems, translating word problems into mathematical equations. Solving various types of word problems involving arithmetic operations. Data analysis, applying arithmetic concepts to analyze and interpret data. Using arithmetic in the context of linguistic research, e.g. calculating frequencies, analyzing distributions. Assessment, quizzes, short quizzes to assess understanding of key concepts. Midterm exam, a comprehensive exam covering the first half of the course material. Final exam, a comprehensive exam covering all course material. Note, this is a sample syllabus and may be adjusted based on the specific needs and goals of the course. 1. The Language Lab budget. Scenario: the linguistics department needs to budget for a new language lab. Equipment costs include 15 noise-canceling headphones at $75 each. 10 high-quality microphones at $120 each. 3 powerful computers at $1,500 each. Software licenses for 15 workstations at $250 per license. Task: calculate the total cost of each equipment type. Determine the total cost of the entire language lab setup. If the department has a budget of $10,000, how much more funding is needed to? Analyzing text message frequencies. Scenario: a researcher is studying the frequency of different emoji usage in a large dataset of text messages. Data: provided with a table showing the number of occurrences for each of the top 10 emojis. Task: calculate the total number of emojis used. Determine the percentage of occurrences for each emoji. Create a simple bar graph to visualize the emoji frequency distribution. 3 word count and average word length. Scenario: a student is analyzing a short story. Data: provided with the text of the short story. Task: count the total number of words in the story. Calculate the average word length by dividing the total number of letters by the total number of words. For the traveling linguist. Scenario: a linguist is planning a research trip to 3 different countries. Data: provided with estimated travel costs, flights, accommodation for each country, daily living expenses, food, transportation for each country, research budget. Task: calculate the estimated total cost for each country. Determine the maximum number of days the linguist can spend in each country within the research budget. 5. Analyzing language diversity in a community. Scenario: a community organization is interested in understanding the linguistic diversity within their area. Data: provided with a table showing the number of native speakers for the top 5 languages spoken in the community. Task: calculate the total number of native speakers. Determine the percentage of the population represented by each language group. Consider how this data can be used to inform community outreach programs and services. 6. The Phonetic Transcription Project. Scenario: a phonetics lab is transcribing audio recordings of speech. Data: provided with information about the number of hours of audio to be transcribed, the number of transcribers available, and the average transcription rate per hour per transcriber. Task: calculate the total number of transcription hours required. Determine how many days it will take to complete the project, assuming an 8-hour workday. Explore the impact of hiring additional transcribers on the project timeline. 7. Analyzing language learning progress. Scenario: a language learner is tracking their vocabulary growth. Data: provided with a table showing the number of new vocabulary words learned each week. Task: calculate the total number of words learned over a specific period, e.g. a month. Determine the average number of words learned per week. Create a line graph to visualize the learner's vocabulary growth over time. 8. The Linguistics Conference Budget. Scenario: a student is planning to attend a linguistics conference. Data: provided with information on conference registration fees, travel costs, flights, accommodation, estimated daily expenses, food, transportation. Task: calculate the total estimated cost of attending the conference. Create a budget and identify potential areas for cost savings. Explore options for funding or scholarships to help cover expenses. 9. Analyzing survey results. Scenario: a researcher conducted a survey to investigate language attitudes in a particular community. Data: provided with a table summarizing the survey results, e.g. percentages of respondents who agree or disagree with certain statements. Task: calculate the total number of respondents. Determine the number of respondents who answered each question in a specific way. Analyze the data to identify trends and draw conclusions about language attitudes in the community. 10. The Comparative Linguistics Project. Scenario: A group of students is comparing the sound systems of two related languages. Data, provided with lists of phonemes for each language. Task, count the total number of phonemes in each language. Identify shared phonemes between the two languages. Calculate the percentage of shared phonemes. Draw conclusions about the degree of phonetic similarity between the two languages. Week 1. One whole number mastery, counting, fluency, develop effortless counting forward and backward. Skip counting, practice skip counting by 2s, 5s, 10s, etc. Basic operations, addition and subtraction, master single-digit and multi-digit addition and subtraction facts. Multiplication and division, understand the concepts of multiplication, repeated addition and division, sharing equally. Practice multiplication tables. 2. Place value, understanding, deeply understand the concept of place value, ones, tens, hundreds, etc. Application, apply place value to accurately perform addition, subtraction, multiplication, and division with multi-digit numbers. 3. Number sense, comparing numbers, develop the ability to compare numbers greater than, less than, equal to. Rounding, learn to round numbers to the nearest 10, 100, etc. Estimation, develop estimation skills to approximate answers to calculations. 4. Problem solving, word problems, practice translating word problems into mathematical equations and solving them. Real-world application, connect arithmetic concepts to everyday situations, e.g. shopping, cooking, measuring. 11. The Sociolinguistics Survey, scenario, a team of sociolinguists is analyzing survey data on language use in a particular community. Data, provided with a table showing the percentage of respondents who use different language varieties in various social situations, e.g. at home, at work, with friends. Task, calculate the percentage of respondents who use each language variety in each social situation. Analyze the data to identify patterns of language use and potential sociolinguistic factors influencing language choice. 12. The Phonetics Lab Experiment, scenario, a phonetics lab is conducting an experiment to measure the duration of different vowel sounds. Data, provided with a set of audio recordings and a table to record the duration of each vowel sound in milliseconds. Task, measure and record the duration of each vowel sound in the recordings. Calculate the average duration for each vowel sound. Analyze the data to identify any significant differences in the duration of different vowel sounds. 13. The Language Learning App Usage, scenario, a language learning app developer is analyzing user data to track app usage and identify areas for improvement. Data, provided with data on the number of daily active users, the average daily usage time, and the most popular language courses. Task, calculate the total number of active users over a specific period. Determine the average daily usage time per user. Analyze the data to identify the most popular language courses and user engagement trends. 14. The Comparative Grammar Study, scenario, a linguist is comparing grammatical features in two related languages. Data, provided with data on the frequency of occurrence of specific grammatical constructions in a set of texts from each language. Task, calculate the frequency of each grammatical construction in each language. Compare the frequencies of the constructions across the two languages. Analyze the data to identify similarities and differences in the grammatical structures of the two languages. 15. The Dialectology Fieldwork Project, scenario, a team of dialectologists is conducting fieldwork to collect data on regional variations in pronunciation. Data, provided with audio recordings of interviews with speakers from different regions. Task, analyze the recordings to identify regional variations in the pronunciation of specific sounds. Tabulate the frequency of different pronunciations in each region. Create a map to visualize the geographic distribution of different pronunciation variants. 16. The recipe scaling case study. Scenario: you have a recipe for a certain number of servings, but you need to adjust it to make more or fewer servings. Data: provided with the original recipe ingredients and the desired number of servings. Task: calculate the scaling factor, the ratio of desired servings to original servings. Adjust the amount of each ingredient accordingly using the scaling factor. 17. The travel budget case study. Scenario: you are planning a trip and need to create a budget to ensure you stay within your financial limits. Data: provided with estimated costs for transportation, accommodation, food, entertainment, and other expenses. Task: calculate the total estimated cost of the trip, determine the daily budget to stay within your overall travel fund. Identify potential areas where you can cut costs to stay within budget. 18. The sales tax case study. Scenario: you are shopping for items and need to calculate the total cost, including sales tax. Data: provided with the price of the items and the local sales tax rate. Task: calculate the amount of sales tax for each item. Calculate the total cost of each item, including sales tax. Calculate the total cost of all items purchased, including sales tax. 19. The unit conversion case study. Scenario: you need to convert measurements between different units, e.g. inches to centimeters, pounds to kilograms, miles to kilometers. Data: provided with the value in the original unit and the conversion factor. Task: use the conversion factor to convert the value to the desired unit. 20. The data analysis case study. Scenario: you are given a set of numerical data, e.g. test scores, daily temperatures, stock prices. Task: calculate the mean average of the data set. Find the median middle value of the data set. Determine the range difference between the highest and lowest values of the data set. Optional: create a simple graph like a bar graph or line graph to visualize the data. Week 2. 1. Focus on percentages and proportions. Case studies 11, 13, and 16. These cases heavily involve percentages and proportions. Sociolinguistics survey, calculating percentages of respondents using different language varieties. Language learning app usage, analyzing usage data and calculating percentages of user engagement. Recipe scaling, determining the scaling factor or ratio to adjust recipe ingredients. 2. Introduce the concept of averages. Case studies 12 and 20. These cases introduce the concept of averages, mean, median. Phonetics lab experiment, calculating the average duration of vowel sounds. Data analysis, finding the mean average of a given data set. 3. Emphasize data analysis and interpretation. Case studies 11 to 15. These cases all require students to analyze data, identify patterns, and draw conclusions. Sociolinguistics survey, analyzing patterns of language use and identifying sociolinguistic factors. Phonetics lab experiment, analyzing data to identify significant differences in vowel sound durations. Language learning app usage, analyzing user engagement trends and identifying the most popular language courses. Comparative grammar study, comparing grammatical frequencies and identifying similarities, differences. Dialectology fieldwork project, analyzing regional variations in pronunciation and visualizing data on a map. 4. Introduce basic data visualization. Case studies 12, 13, and 20. These cases hint at data visualization. Phonetics lab experiment, while not explicitly stated, students could create a simple graph, e.g. bar graph, to compare vowel sound durations. Language learning app usage. Students could explore creating a simple graph to visualize user engagement trends or the popularity of language courses. Data analysis case study. The case study explicitly suggests creating a simple graph, e.g. bar graph, line graph, to visualize the data. 5. Connect to real-world applications. Emphasize the relevance of these concepts to real-world situations, such as personal finance, travel budgeting case study 17, calculating sales tax case study 18. Everyday life, recipe scaling case study 16, unit conversions case study 19. Career paths. Data analysis skills are valuable in many fields, including linguistics, research, and business. 21. The comparative lexicography case study. Scenario: a team of lexicographers is comparing the sizes of two dictionaries for different languages. Data, provided with the total number of entries in each dictionary. Task: calculate the difference in the number of entries between the two dictionaries. Determine the percentage difference in size between the two dictionaries. Consider what factors might contribute to the difference in dictionary size, e.g. the complexity of the languages, the scope of the dictionaries. 22. The archaeological excavation case study. Scenario: an archaeological team is excavating a site and needs to record the depth of various artifacts found. Data, provided with a table of artifacts and their depths below the surface in meters or centimeters. Task: calculate the range of depths at which artifacts were found. Determine the average depth of all the artifacts. Analyze the data to identify any patterns in the distribution of artifacts at different depths. 23. The acoustic phonetics analysis case study. Scenario: an acoustic phonetician is analyzing the formant frequencies of different vowels. Data, provided with a table of formant frequencies measured in hertz for a set of vowel sounds. Task: calculate the average formant frequency for each vowel. Compare the formant frequencies of different vowels to identify acoustic differences. Optional: use the data to plot formant values on a vowel chart if applicable. 24. The psycholinguistics experiment case study. Scenario: a psycholinguist is conducting an experiment on word recognition times. Data, provided with a table of reaction times measured in milliseconds for participants to identify words presented visually or auditorily. Task: calculate the average reaction time for each presentation modality: visual, auditory. Compare the average reaction times to determine if there is a significant difference in word recognition speed between the two modalities. 25. The language attrition case study. Scenario: a researcher is studying language attrition in bilingual speakers. Data, provided with data on the frequency of use of the minority language in different domains, e.g. home, work, social, for a group of bilingual speakers. Task: calculate the average frequency of minority language use across different domains. Analyze the data to identify factors that may be contributing to language attrition, e.g. age, level of education, exposure to the minority language. 26. The phoneme inventory case study. Scenario: a linguist is comparing the phoneme inventories of two closely related languages. Data, provided with lists of phonemes for each language. Task: calculate the total number of phonemes in each language. Determine the number of phonemes shared by both languages. Calculate the percentage of shared phonemes. Analyze the data to make inferences about the historical relationship between the two languages. 27. The language acquisition case study. Scenario: a researcher is studying the vocabulary growth of a child learning their first language. Data, provided with data on the number of words in the child's vocabulary at different ages. Task: calculate the average rate of vocabulary growth per month. Determine the period of most rapid vocabulary growth. Create a line graph to visualize the child's vocabulary development over time. 28. The Speech Error Analysis Case Study. Scenario: a speech-language pathologist is analyzing speech errors made by a client. Data: provided with a list of speech errors, e.g. substitutions, omissions, additions. Task: calculate the total number of speech errors. Determine the frequency of each type of speech error. Calculate the percentage of each error type. Analyze the data to identify patterns in the client's speech errors. 29. The Text Analysis Case Study. Scenario: a researcher is analyzing the frequency of different word classes, nouns, verbs, adjectives, etc. in a large corpus of text. Data: provided with a table of word frequencies for each word class. Task: calculate the total number of words in the corpus. Calculate the percentage of each word class in the corpus. Create a pie chart to visualize the proportion of each word class. 30. The Sociolinguistic Interview Analysis Case Study. Scenario: a sociolinguist is analyzing data from interviews with speakers of different social dialects. Data: provided with data on the frequency of use of specific linguistic features, e.g. grammatical constructions, pronunciation variants by speakers from different social groups. Task: calculate the average frequency of each linguistic feature for each social group. Compare the frequencies of linguistic features across different social groups. Analyze the data to identify social factors that may influence language use. Midterm exam, Introductory Arithmetic. Week 3. Instructions: answer all questions to the best of your ability. Show all your work for full credit. You may use a calculator for this exam. Part 1, multiple choice, 2 points each. Which of the following is the correct order of operations: A, addition, subtraction, multiplication, division; B, parentheses, exponents, multiplication, division, addition, subtraction; C, multiplication, division, addition, subtraction; D, exponents, parentheses, addition, subtraction, multiplication, division. What is 25% of 80? A, 16, B, 20, C, 25, D, 32. If a recipe calls for 2 cups of flour and you want to make half the recipe, how much flour do you need? A, 1 cup, B, 1.5 cups, C, 2.5 cups, D, 4 cups. What is the average of the following numbers: 10, 15, 20, 25? A, 15, B, 17.5, C, 20, D, 22.5. Convert 5 feet to inches. A, 40 inches, B, 50 inches, C, 60 inches, D, 70 inches. Part 2, short answer, 5 points each. Calculate: A, 15 to 3x 2 plus 8b 10 plus 5 divided by 3. A store is having a 20% off sale. If a shirt originally costs 30, how much will it cost after the discount? A recipe calls for 3-4 Cuban pesos of sugar. You only have 1-2 Cuban pesos of sugar. How much more sugar do you need? Find the mean, median, and range of the following data set: 8, 12, 5, 18, 12. Part 3, Essay, 20 points. Choose one of the following essay topics. Case Study 21, Comparative Lexicography. Discuss how you would use the data provided, total number of entries in each dictionary, to analyze the potential factors that might contribute to the difference in dictionary size. Consider factors such as the complexity of the languages, the scope of the dictionaries, and historical influences. Case Study 27, Language Acquisition. Explain how you would use the data on the child's vocabulary growth to identify potential critical periods or stages in language development. Discuss the implications of this data for understanding language acquisition processes. Grading rubric: multiple choice, 2 points per correct answer. Short answer: 5 points per question, awarded based on accuracy and completeness of the solution. Essay, 20 points total, awarded based on clarity and organization of thought, depth of analysis and critical thinking, accuracy and relevance of information, grammar and mechanics. Note, this is a sample midterm exam and may need to be adjusted based on the specific learning objectives and difficulty level of your course. This midterm exam covers a range of topics from the first 3 weeks of the course, including basic arithmetic operations, order of operations, fractions, percentages, averages, data analysis, problem solving. The essay question encourages students to apply their knowledge to a real-world scenario and demonstrate their understanding of key concepts in a more in-depth manner. 31. The language contact case study, scenario, a linguist is investigating the influence of one language on another in a contact situation. Data, provided with data on the frequency of borrowing from the dominant language into the minority language. Task, calculate the total number of borrowings. Determine the percentage of borrowed words in the minority language vocabulary. Analyze the data to identify the areas of vocabulary most affected by borrowing, e.g. technology, food, culture. 32. The socio-linguistics variation case study, scenario, a sociolinguist is studying the use of multiple negation in a particular dialect. Data, provided with data on the frequency of multiple negation in the speech of different age groups within the community. Task, calculate the average frequency of multiple negation for each age group. Analyze the data to determine if there is a significant difference in the use of multiple negation across age groups. Discuss the potential implications of this variation for the future of the dialect. 33. The psycholinguistics sentence processing case study, scenario, a psycholinguist is investigating the processing difficulty of different sentence structures. Data, provided with data on the reading times for sentences with different syntactic structures. Task, calculate the average reading time for each sentence type. Analyze the data to determine which sentence structures are processed more quickly or more slowly. Discuss the potential cognitive mechanisms underlying these processing differences. 34. The computational linguistics natural language processing case study, scenario, a computational linguist is developing a sentiment analysis system to classify text as positive, negative, or neutral. Data, provided with a dataset of labeled text positive, negative, neutral, and the system's predictions. Task, calculate the accuracy of the sentiment analysis system percentage of correctly classified texts. Identify the types of text that the system is most likely to misclassify. Suggest potential improvements to the system's accuracy. 35. The historical linguistics sound change case study, scenario, a historical linguist is investigating the regularities of sound change in a language family. Data, provided with data on the historical development of a set of sounds in a group of related languages. Task, analyze the data to identify systematic sound correspondences across the languages. Formulate sound change rules to account for the observed correspondences. Use these rules to reconstruct the proto-language from which the daughter languages descended. 36. The discourse analysis turn-taking patterns case study, scenario, a discourse analyst is investigating turn-taking patterns in conversations between children and adults. Data, provided with transcripts of conversations between children of different ages and their caregivers. Task, calculate the average length of speaker turns for both children and adults. Analyze the frequency of interruptions and overlaps in speech for each participant group. Determine if there are significant differences in turn-taking patterns between children and adults. 37. The psycholinguistics memory span case study, scenario, a psycholinguist is investigating the effects of age on verbal short-term memory span data, provided with data on the number of words that participants of different ages can recall in immediate serial recall tasks. Task: calculate the average memory span for each age group. Analyze the data to determine if there is a significant decline in memory span with age. Discuss the implications of these findings for theories of aging and cognitive decline. 38. The Computational Linguistics Sentiment Analysis Case Study. Scenario: a computational linguist is developing a system to classify social media posts as expressing positive, negative, or neutral sentiment. Data: provided with a dataset of social media posts labeled with their sentiment positive, negative, neutral, and the system's predictions. Task: calculate the accuracy, precision, recall, and F1 score of the sentiment analysis system. Identify the linguistic features, e.g. the use of specific words, emoticons, punctuation that the system uses to make its predictions. Suggest ways to improve the system's performance, such as incorporating more sophisticated machine learning techniques or expanding the training data. 39. The Sociolinguistics Language Change Case Study. Scenario: a sociolinguist is investigating the spread of a new linguistic feature within a community. Data: provided with data on the frequency of use of the new linguistic feature by speakers of different ages and social groups. Task: analyze the data to determine the rate of diffusion of the new feature within the community. Identify the social factors that may be influencing the spread of the new feature. Discuss the potential social and linguistic consequences of the diffusion of this new feature. 40. The Phonetics Acoustic Analysis Case Study. Scenario: an acoustic phonetician is analyzing the acoustic characteristics of different vowels in a particular dialect. Data: provided with acoustic measurements, e.g. formant frequencies, duration for a set of vowel sounds produced by speakers of the dialect. Task: calculate the mean and standard deviation of formant frequencies for each vowel. Analyze the data to identify acoustic differences between different vowels in the dialect. Create a vowel chart to visualize the acoustic space of the vowels in the dialect. Week 4. We'll start by revisiting important ideas like percentages, averages, and how to analyze data, making sure everyone has a solid grasp of these fundamentals. Next, we'll explore some new tools and techniques. You'll learn how to create visual representations of data like bar graphs and line graphs, which can make patterns and trends much clearer. We'll also delve into some basic statistical concepts, such as standard deviation and variance, to help you understand how spread out the data is. Finally, you'll learn about correlation, which helps us see how different factors might be related. 41. The Sociolinguistics Indexicality Case Study. Scenario: a sociolinguist is investigating how linguistic features index social identity in a particular community. Data: provided with transcripts of conversations and observations of social interactions within the community. Task: identify linguistic features, e.g. pronunciation variants, vocabulary choices, grammatical constructions that are associated with specific social groups or identities within the community. Analyze how these linguistic features index social factors such as age, gender, social class, ethnicity, and regional origin. Discuss the social meanings and functions of these linguistic features. 42. The Psycholinguistics Tip of the Tongue Phenomenon Case Study. Scenario: a psycholinguist is investigating the tip of the tongue taught phenomenon, where individuals know they know a word but cannot immediately retrieve it. Data: provided with data on the characteristics of words that are most likely to elicit a taught state, e.g. word frequency, word length, semantic similarity to other words. Task: analyze the data to identify factors that increase the likelihood of experiencing a taught state. Discuss the implications of these findings for models of lexical retrieval and memory. 43. The Computational Linguistics Information Retrieval Case Study. Scenario: a computational linguist is developing a system to retrieve relevant documents from a large collection of text, e.g. a library catalog, a news archive. Data: provided with a set of queries and the relevant documents retrieved by the system. Task: evaluate the performance of the information retrieval system using metrics such as precision, recall, and F-measure. Analyze the types of queries that the system struggles to handle effectively. Suggest potential improvements to the system's retrieval accuracy. 44. The Historical Linguistics Language Family Reconstruction Case Study. Scenario: a historical linguist is attempting to reconstruct the proto-language of a particular language family. Data: provided with data on the sound systems and vocabularies of a set of related languages. Task: analyze the data to identify systematic sound correspondences across the languages. Reconstruct the proto-language's phoneme inventory and vocabulary based on the observed correspondences. Discuss the uncertainties and limitations of language reconstruction. 45. The Sociolinguistics Language Attitudes Case Study. Scenario: a sociolinguist is investigating attitudes towards different language varieties within a speech community. Data: provided with data from surveys, interviews, and observational studies on speakers' attitudes towards different accents, dialects, and languages. Task: analyze the data to identify patterns of language attitudes within the community. Discuss the social and psychological factors that shape these attitudes. Examine the potential social consequences of these language attitudes. 46. The Sociolinguistics Dialect Contact Case Study. Scenario: a sociolinguist is investigating the influence of a dominant dialect on a less prestigious dialect in a region where the two languages are in contact. Data: provided with data on the frequency of features from the dominant dialect appearing in the speech of speakers of the less prestigious dialect. Task: calculate the percentage of utterances in the speech of speakers of the less prestigious dialect that contain features from the dominant dialect. Analyze the data to identify which linguistic features are most likely to be borrowed from the dominant dialect. Discuss the potential social and linguistic consequences of dialect contact and language change. 47. The Psycholinguistics Tip of the Tongue Phenomenon Case Study 2. Scenario: a psycholinguist is investigating the relationship between age and the frequency of tip of the tongue taught experiences. Data: provided with data on the number of taught experiences reported by participants of different age groups over a specific period. Task: calculate the average number of taught experiences per participant for each age group. Analyze the data to determine if there is a significant relationship between age and the frequency of taught experiences. Discuss the potential cognitive and neurological factors that may contribute to the age-related changes in taught frequency. 48. The Computational Linguistics Text Classification Case Study 2. Scenario: a computational linguist is developing a system to classify online reviews, e.g. restaurant reviews, product reviews as positive, negative, or neutral. 1. Data: provided with a dataset of online reviews labeled with their sentiment positive, negative, neutral, and the system's predictions. Task: calculate the accuracy, precision, recall, and F1 score of the sentiment analysis system. Analyze the system's performance on reviews of different lengths and topics. Suggest ways to improve the system's performance by incorporating features such as sentiment lexicons, lists of words with positive or negative connotations, or sentiment-specific emoticons. 49. The Historical Linguistics Sound Change Regularity Case Study 2. Scenario: a historical linguist is investigating the relationship between the frequency of sounds in a language and the likelihood of those sounds undergoing sound change. Data: provided with data on the frequency of occurrence of different phonemes in a set of languages within a language family. Task: analyze the data to determine if there is a correlation between phoneme frequency and the likelihood of that phoneme undergoing sound change. Discuss the potential implications of this finding for theories of language change and the evolution of sound systems. 50. The Sociolinguistics Language Variation and Social Networks Case Study. Scenario: a sociolinguist is investigating the spread of a new linguistic feature within a social network. Data: provided with data on the social connections between individuals in a community and the adoption of the new linguistic feature by each individual. Task: create a social network graph to visualize the connections between individuals in the community. Analyze the network to identify key individuals or groups that may act as opinion leaders or influencers in the diffusion of the new linguistic feature. Discuss the role of social networks in shaping language variation and change. Week 5. Key considerations. 1. Introduction to probability. Basic concepts. Start with fundamental concepts like events, outcomes, and the likelihood of events occurring. Simple probability. Introduce the calculation of simple probabilities, e.g. flipping a coin, rolling a die. Real-world examples. Connect probability concepts to real-world situations relevant to linguistics, such as the likelihood of certain sounds occurring in a particular language or the probability of encountering specific words in a text. 2. Data analysis and visualization. Frequency distributions. Introduce the concept of frequency distributions, e.g. histograms, bar charts to visualize the distribution of data. Measures of central tendency and variability. Review and expand on measures of central tendency: mean, median, mode, and measures of variability: range, standard deviation. Data interpretation. Emphasize the importance of interpreting data visualizations and drawing meaningful conclusions from the analysis. 3. Case studies. Focus on probability and data analysis. Select case studies that explicitly involve probability and statistical analysis. For example, predicting the likelihood of specific sound changes, based on historical data. Predict the probability of certain sound changes occurring in a given language. Analyzing the distribution of word frequencies. Investigate the distribution of word frequencies in a large corpus of text and compare it to Zipf's law, a law that describes the distribution of word frequencies in many natural languages. Modeling language learning. Explore probabilistic models of language acquisition, such as how children learn to associate sounds with meanings. Case Study 51. Predicting the likelihood of vowel reduction in English. Focus: probability, historical linguistics. Scenario: in English, unstressed vowels often undergo reduction, becoming shorter and less distinct. 1. For example, the vowel in about is typically reduced in casual speech. Analysis: collect data on the frequency of vowel reduction in different English dialects. Identify factors that may influence the likelihood of reduction, e.g. word position, stress pattern, speaking rate. Use probability models, e.g. logistic regression, to predict the probability of vowel reduction in new words or in different speech contexts. Case Study 52. Analyzing the distribution of word lengths in Shakespeare. Focus: data analysis, frequency distributions, literary linguistics. Scenario: investigate the distribution of word lengths in Shakespeare's plays. Analysis: collect data on the lengths of words in a representative sample of Shakespeare's works. Create a frequency distribution of word lengths, e.g. histogram. Calculate measures of central tendency: mean, median, and variability standard deviation. Compare the observed distribution to theoretical distributions, e.g. normal distribution, and discuss any deviations. Case Study 53. Modeling the acquisition of phonological rules. Focus: probability, language acquisition. Scenario: Children acquire the phonological rules of their native language through exposure and experience. Point 2. Analysis. Develop a probabilistic model that simulates how children might learn a specific phonological rule, such as the process of consonant cluster simplification, e.g. strong becoming stong. Use the model to predict children's errors in pronunciation at different stages of development. Compare the model's predictions to actual child language data to evaluate its accuracy. Case Study 54, Investigating the Zipf's law in different genres of text. Focus, data analysis, frequency distributions, computational linguistics. Scenario, Zipf's law states that the frequency of a word is inversely proportional to its rank in the frequency table. Point 3. Analysis. Analyze the frequency distributions of words in different genres of text, e.g. news articles, novels, poetry. Calculate the slope of the rank frequency plot for each genre. Determine whether Zipf's law holds true across different genres and investigate any deviations. Case Study 55, Predicting the likelihood of code switching in bilingual speech. Focus, probability, sociolinguistics. Scenario, bilingual speakers often switch between their two languages within a single conversation. Point 4. Analysis. Collect data on code switching behavior in a specific bilingual community. Identify factors that may influence the likelihood of code switching, e.g. topic of conversation, social context, interlocutor. Use probabilistic models, e.g. logistic regression, decision trees to predict the probability of code switching in different situations. Case Study 56, Analyzing the distribution of syllable structures in a language. Focus, data analysis, frequency distributions, phonology. Scenario, investigate the distribution of syllable structures, e.g. CVC, CV, CCV in a particular language. Analysis, collect a large corpus of words from the target language. Determine the frequency of occurrence for each syllable structure. Create a frequency distribution and visualize it using a bar chart or pie chart. Compare the observed distribution to potential constraints on syllable structures in the language, e.g. limitations on consonant clusters. Case Study 57, Predicting the likelihood of mispronunciation in second language acquisition. Focus, probability, second language acquisition, phonology. Scenario, explore the factors that influence the likelihood of L2 learners mispronouncing specific sounds or sound sequences. Analysis, collect data on the pronunciation errors made by L2 learners of a particular language. Identify potential predictors of mispronunciation, e.g. L1 phonological system, exposure to the L2, age of acquisition. Use probabilistic models, e.g. logistic regression, decision trees to predict the likelihood of mispronunciation for specific sounds or sound combinations. Case Study 58, Analyzing the distribution of sentence lengths in different literary styles. Focus, data analysis, frequency distributions, stylistics. Scenario, compare the distribution of sentence lengths in different literary styles, e.g. poetry, prose, drama. Analysis, collect data on sentence lengths measured in words or number of clauses from a variety of literary texts. Create frequency distributions and calculate measures of central tendency and variability for each style. Conduct statistical tests, e.g. t-tests, ANOVA, to determine if there are significant differences in sentence length distributions across styles. Case Study 59, Modeling the evolution of language change. Focus, probability, historical linguistics. Scenario, simulate the evolution of a particular linguistic feature, e.g. vowel shifts, grammatical changes over time. Analysis, develop a probabilistic model that incorporates factors such as random drift, selection pressures e.g. ease of articulation, and social factors. Run simulations to observe how the linguistic feature changes over multiple generations. Compare the model's predictions to actual historical data to evaluate its accuracy. Case Study 60, Analyzing the relationship between language complexity and cognitive load. Focus, data analysis, psycholinguistics, cognitive science. Scenario, investigate the relationship between the complexity of linguistic structures e.g. syntactic complexity, lexical density, and cognitive load during language processing. Analysis, collect data on measures of cognitive load e.g. reaction times, eye tracking data while participants process sentences of varying complexity. Analyze the relationship between linguistic complexity measures and cognitive load using statistical methods e.g. correlation analysis, regression analysis. Explore how factors such as individual differences e.g. language proficiency, working memory capacity may influence the relationship between complexity and cognitive load. Case Study 61, Analyzing the impact of social media on language change. Focus, data analysis, sociolinguistics, language change. Scenario, investigate how social media platforms influence the evolution of language, including the spread of neologisms, slang, and changes in grammatical constructions. Analysis, collect data from social media platforms e.g. Twitter, Instagram, TikTok to track the emergence and diffusion of new linguistic features. Analyze the frequency and distribution of these features across different demographics and social networks. Use statistical methods to identify correlations between social media usage and the rate of language change. Case Study 62, Predicting Reading Comprehension Difficulties. Focus, data analysis, psycholinguistics, education. Scenario, develop a model that predicts reading comprehension difficulties in children based on linguistic and cognitive factors. Analysis, collect data on children's reading comprehension scores, vocabulary knowledge, phonological awareness, working memory capacity, and other relevant factors. Use machine learning algorithms e.g. logistic regression, support vector machines to build a predictive model. Evaluate the model's accuracy and identify the most important predictors of reading comprehension difficulties. Case Study 63, Analyzing the impact of bilingualism on cognitive function. Focus, data analysis, psycholinguistics, cognitive science. Scenario, investigate the cognitive benefits of bilingualism, such as improved executive function, attention, and problem-solving skills. Analysis, collect data on cognitive performance e.g. working memory tasks, attention tests from monolingual and bilingual individuals. Compare the performance of the two groups using statistical tests. Explore potential moderating factors, such as age of acquisition of the second language and level of proficiency. Case Study 64, Analyzing the distribution of dialectal features in a geographic region. Focus, data analysis, dialectology, sociolinguistics. Scenario, investigate the geographic distribution of specific dialectal features e.g. pronunciation variants, grammatical constructions within a particular region. Analysis, collect data on the usage of dialectal features from speakers across the region. Create maps to visualize the geographic distribution of the features. Use statistical methods e.g. spatial analysis, cluster analysis to identify dialect boundaries and understand the factors that contribute to dialect variation. Case Study 65, Modeling the Evolution of Sign Languages. Focus, probability, historical linguistics, sign language linguistics. Scenario, develop a probabilistic model to simulate the evolution of sign language features, such as hand shapes, locations, and movements. Analysis: consider factors such as contact with other sign languages, iconicity, and constraints on hand movements. Run simulations to observe how the sign language system changes over time. Compare the model's predictions to the observed evolution of real-world sign languages. These case studies expand on the previous set, exploring a wider range of topics within linguistics and demonstrating the versatility of probability and data analysis in addressing complex research questions. Week 6. Final case study. 1. Arithmetic beyond basic operations. Focus: this interpretation emphasizes skills beyond the 4 basic operations: addition, subtraction, multiplication, division. It often includes fractions and decimals, working with complex fractions, mixed numbers, decimal operations, and converting between fractions and decimals. Percentages: calculating percentages, finding the original amount, and solving problems involving discounts, markups, and interest. Ratios and proportions: understanding and solving problems involving ratios, proportions, and rates. Exponents and roots: working with exponents, square roots, and other roots. Number theory: exploring concepts like prime numbers, divisibility rules, and the greatest common divisor. 2. Pre-algebra. Focus: this interpretation views advanced arithmetic as a bridge between basic arithmetic and algebra. It may include introduction to algebraic concepts, working with variables, simplifying expressions, solving simple equations, and graphing linear equations. Number lines and inequalities: understanding number lines, inequalities, and absolute value. Order of operations: mastering the order of operations PEMDAS BODMAS. 3. Advanced topics for specific purposes. Focus: this interpretation tailors advanced arithmetic to specific fields or applications. For example, financial mathematics, dealing with compound interest, annuities, and other financial calculations. Statistical arithmetic, involving calculations related to mean, median, mode, standard deviation, and other statistical measures. In essence, advanced arithmetic generally refers to a deeper level of understanding and application of arithmetic concepts beyond basic addition, subtraction, multiplication, and division. It often involves more complex calculations, problem solving, and the introduction of more sophisticated mathematical ideas. Final exam. 1. Multiple choice or true-false questions, 25 to 35% of the grade. Focus: knowledge recall, test basic understanding of key concepts, definitions, and theories covered throughout the course. Conceptual understanding, assess comprehension of core ideas and their interconnections. Example: which of the following is not a characteristic of a fricative consonant? True or false? Noam Chomsky's theory of universal grammar posits that all human languages share an innate set of linguistic rules. If a fair coin is flipped twice, what is the probability of obtaining 2 heads? Requires basic probability calculations. True or false? In a Zipfian distribution, the frequency of the most frequent word is approximately twice that of the second most frequent word. Assesses understanding of a mathematical principle in linguistics. 2 short answer questions, 25 to 35% of the grade. Focus: application of knowledge, requires students to apply concepts to specific examples or scenarios. Analysis: encourage brief explanations and interpretations of linguistic phenomena. Example: explain the difference between phonetics and phonology. Describe the concept of semantic ambiguity and provide an example. Briefly discuss the role of social factors in language variation. Calculate the mean and standard deviation of the following set of word lengths: 3, 5, 2, 4, 7. Requires basic statistical calculations. Describe how you would quantify the degree of phonetic similarity between two sounds using a feature matrix. Prompts consideration of a quantitative approach to sound comparison. Explain the concept of information entropy in the context of language. How can it be used to measure the predictability of a text requires understanding of a mathematical concept in information theory. 3 essay question 40 to 50% of the grade. Focus, critical thinking and analysis, assess higher order thinking skills such as synthesis, evaluation, and argumentation. Demonstrating in-depth understanding, allows students to demonstrate a comprehensive grasp of course material and its implications. Example, discuss the impact of globalization on language diversity. Consider factors such as language endangerment, language revitalization, and the emergence of global languages. Analyze the relationship between language and culture, drawing on specific examples from different societies. Evaluate the strengths and weaknesses of different approaches to language acquisition. Discuss the application of Markov models in natural language processing. Explain the mathematical principles underlying Markov chains and provide specific examples of how they are used in tasks such as part of speech tagging or language generation. Analyze the relationship between language complexity and processing time. Discuss how measures such as sentence length, syntactic depth, and lexical density can be quantified and how they correlate with cognitive load. Evaluate the strengths and weaknesses of different computational approaches to language modeling, considering factors such as accuracy, computational efficiency, and the ability to capture complex linguistic phenomena. Tips for preparing for the essay: practice writing essays, regularly practice writing short essays on potential essay topics. This will help you develop your writing skills and identify areas for improvement. Develop an outline. Before writing, create a brief outline to structure your arguments and ensure a logical flow. Use specific examples. Support your arguments with concrete examples from the course readings, lectures, and class discussions. Cite your sources. If you refer to any external sources, make sure to properly cite them. Proofread carefully. Review your essay for any grammatical errors or typos before submitting.
Welcome to the class, the numbers play. We count back and dance the modern stage. Mine is here and there, feel the beat. Numbers on the move, can't take a seat. Multiplying wild, subtraction's cool. Jump into the groove, arithmetic's the rule. Fours and fives, we break it down. Oh yeah, in this math jam, but where we're found. 1, 2, 3, 4, let's add more. Feel that number groove, dance on the floor. Subtracting beats with every spin. Arithmetic's our jam, let's all win. Arithmetic flows, it's how we roll. Feel the numbers move, let's take control. Adding up the joy, subtracting fears. In this great groove, math is cheers. 1, 2, 3, 4, let's add more. Feel that number groove, dance on the floor.